Hello students, this is the 13th video that I prepared to explain how to use this Casio graphic display calculator. So let us continue. Um, in this video we're going to solve problems based on normal distribution. Okay. So the 44th problem. The heights of a group of students are normally distributed with a mean of 160 centimeter and a standard deviation of 20 centimeter. So the first question is, a student is chosen at random. Find the probability that the student's height is greater than 180 centimeter. So here mean is 160 and standard deviation is 20. We have to find P of x. What is the probability that the height is more than 180? So P of x more than 180. Fine. So menu, stat, distribution. We'll go to normal and then we'll go to NCD. Always NCD. NCD. Okay. Here now I want to find P of x more than 180. That means the lower limit is 180 and the upper limit I'll always take it as 10,000. Okay, sigma is I think 20, standard deviation, yeah, 20 here, and mean is 160 centimeter. Okay, so the answer is 0.159. So the probability, required probability is 0.159. So let us check. Yeah, that is correct, 0.159. Okay. Second one, in this group of students, 11.9% have heights less than d centimeter. So find the value of t. So I can write this statement like this. P of x less than d is equal to 0.119. 11.9% is 0.119. So then I will find the value of t. Now how do I do that? So exit a good distribution, normal. Now if you have to find the probability, then you'll use NCD. Now the probability is given, isn't it? There is, you know the probability, but you need to find the value of d. Okay, so for that, where here d represents the height of students. Okay, so I'll find inverse normal. The tail is left because it is less than d. Okay, so the tail is on the left hand side. The area is 0.119 and sigma and mu are the same. So the answer is 136.399. So three significant figures, it is 136. Yeah, so 136 is the answer, right? Okay, the next problem. The heights h of the people in a certain town are normally distributed with mean 170 centimeter and standard deviation 20. A person is selected at random. Find the probability that his height is less than 185. Again, it's a very similar type of problem. So standard deviation is 20, sigma and mu is 170, and we need to find P of x less than 185. Okay, so exit. I need less than 185. That means the upper limit will be 185 because I want less than 185, and the lower limit will be minus 10,000. Sigma is 20 and mu is 170. So the answer is 0.773. Okay, so for the first question, the answer is 0.773. Let us check. Yeah, that is correct. Now the second one, given that P of h greater than d equal to 0.6808, so find the value of t. Again, we know the probability, but we need to find the value of t. So in this case, we use inverse normal. So exit, distribution normal, inverse normal. Now here, P of h more than d, right? So that means tail is on the right hand side. So tail is right. So I enter F2. And the area is 0.6808. So 0.6808. and mu, sigma and mu are the same, so enter. So x is 160.6, it is 161. So the value of D is 161. Yeah, that is correct. D is 161. Now the 46th problem. A random variable x is distributed normally with a mean of 20 and variance 9. Find p of x less than or equal to 24.5. Now mean is 20 and variance is 9, which means the standard deviation is 3, right? Standard deviation is the square root of variance. Okay, so please be very careful. Okay, so let us go to distribution, normal, NCD, because I need to find the probability here. So I'll go to NCD. I need to find P of x less than or equal to 24.5. So let's say, for example, 24.5 is here. So I need to find this area basically. So a lower limit is minus 10,000, upper limit is 24.5, sigma is 3, and mu is 20. So the answer is 0.933. So 46A, 0.933. Okay. Let P of x less than or equal to k equal to 0.85. Represent this information on the following diagram. Now here, since the probability of x less than or equal to k is 0.85, which is more than 0.5, we know that this area, okay, is 0.5 and this area is 0.5. So less than or equal to k means to the left hand side of k. So you can't have k this side, isn't it? Because if k is to the left hand side of 20, then this area will be 0.85, which doesn't make any sense. So k has to be on the right hand side of 20. So k has to be somewhere here, so that this area to the left of k, the area will be 0.85. So like this, you can see here, k is on the right hand side of 20. Okay. So you get, there are 2 marks for this question. 1 mark is awarded with shading that clearly extends to the right of the mean. Okay, that means this part till here, right of the mean. And 1 mark for any correct label, either k or area or the value of k. Okay, fine. Now, next one is find the value of k. Okay, here the area is given. I need to find the value of k. So I use inverse normal. So exit, distribution, normal, inverse normal. Yeah. Now you can see here, this is the tail, isn't it? So P of x less than or equal to k. This is the region that represents that probability. Now tail is here on the left hand side. So that's what I said. Whenever it is less than or equal to k, tail will be on the left hand side. If it is more than k, let's say more than k, then the tail will be on the right hand side. So tail is left, area is 0.85. Sigma is 3, you may use 20. So the answer is 23.109. So 23.1. Yeah, you get here 23.1. Okay. Fine. So in the bracket, please write that you have used GDC. A random variable x is distributed normally with more, I'm sorry, okay, let us solve the next problem. A random variable x is distributed normally with mean 450 and standard deviation 20. Find P of x less than or equal to 475. Okay, so that's it. Distribution, I need to find the probability, so I'll use NCD. I need to find less than or equal to 475. So the upper limit will be 475. and the lower limit will be minus 10,000. Okay, and sigma is 3, so sigma is 20, and mu is 450. So the area probability is 0.894. So let us check. Yeah, that is correct. The probability is 0.894. Okay. Now P of x more than A equal to 0.27, and find the value of A. So now, if you, let's say if you draw a similar diagram, 450 will be here, isn't it? Mean will be here. And since P of x greater than A, that means we will shade the region which is on the right hand side of A is 0.27. Now again, this area is, since it's less than 0.5, if this is 450, the central line, then A will be somewhere here, isn't it? And after that, I'll shade this area, right? A will be on the right hand side of 450, not on the left hand side. Because if it is on the left hand side of 450, then more than A means, right, this area can't be 0.27, right? So let us check. So here P of x more than A, so tail will be on the right hand side. So exit. Inverse normal, tail is on the right, area is 0.27, sigma is 20, and mu is 450. Yeah. So the answer is 462. Let's check. Yeah, that is correct. 462. Yeah. Now let's do the 48th question. A box contains a large number of biscuits. The weights of biscuits are normally distributed with mean 7 grams and standard deviation 0.5 grams. One biscuit is chosen at random from the box. Find the probability that this biscuit weighs less than 8 grams. Okay, so I have to find P of x less than 8. So mean is 7, standard deviation is 0.5, P of x less than 8. So since I have to find the probability, I'll use NCD. Distribution, normal, NCD. I need to find P of x less than 8, so upper limit will be 8, and lower limit I'll keep it as minus 10,000, and sigma is 0.5, and mu is 7, 9, it's 7. So the probability is 0.977. So for A1, the answer is 0.977. Yeah, that's right, 0.977. What is the probability that this biscuit will weigh between 6 gram and 8 gram? Okay. Now here, in this case, the lower limit will be 6 and upper limit will be 8, because I want to find between 6 and 8. So the answer is 0.954. Okay, between 6 and 8, so that means lower limit will be 6, upper limit will be 8 here. Lower limit 6 and upper limit 8. Yeah. So the answer is 0.944, which is correct. Now B, 5% of the biscuits in the box are weigh less than d grams. Copy and complete the following normal distribution diagram to represent this information by indicating D and shading the appropriate region. Okay, first I will draw the mean here. Send this line, axis. So that will be, you have x equal to 7, isn't it? X equal to 7 here, right? And then 5% of the biscuits in the box weigh less than d grams. So that means P of x less than d is 0.05. 5% is 0.05. So d has to be on the left hand side of 7. So let's say d is somewhere here, and then this area. So let us cross check. Yeah, that's correct. D is here, and then this area. Okay. Now find the value of d. Okay. Here I have to find, I know the area. This is 0.05. I need to find the value of t. So I'll use inverse normal. Here again, you can see that tail is on the left hand side. So exit, distribution, normal, inverse normal, tail is left, area is 0.05, and everything else remains the same. So the value of d is 6.18. Let us check. Yeah, 6.18. That's correct. Fine. Now the last part. The weights of biscuits in another box are normally distributed with mean mu and standard deviation 0.5 grams. It is known that 20% of the biscuits in this second box weigh less than 5 grams. Find the value of mu. Okay, fine. Here you need to get an equation and then solve it. I'm not going to do it here. Okay, that is quite simple. So please do it on your own, students. Okay, so let us look at the 49th problem. Or maybe we can solve it in the next video. Yeah. Thanks for watching this video, students.